Let's have our lecture video in integral calculus with the topic Application of definite integral, plane areas by integration in polar coordinate. Now let's consider here a sector of the circle. So having the sector of the circle here. So this pizza, cite this pizza here. To get the arc length S, we have the formula S is equal to the radius multiplied with the angle here, the angle inside the pizza. For the area, to get the area of that sector, it is 1/2 of the radius times the arc length. Then if we substitute the arc length here for the S, therefore the area of the sector becomes 1/2 r squared theta. The fundamental equation for finding the area enclosed by a curve whose equation is in polar coordinates is based on a sector of a circle with radius r and the central angle delta d theta. Note that r is a polar function, or r is equal to f of theta. Now consider the curve defined by the function r is equal to f of theta, where alpha, so we have here the angle alpha, is less than or equal to the angle theta. So the angle theta here is the angle of the sector. And then the angle theta is less than or equal to the beta. Whenever we sketch a curve for the polar coordinates, we always go to the counterclockwise rotation. So if the angle to be considered is 15 degrees alpha, for example, alpha is equal to 15 degrees, then the rotation of the radius, the given radius, is from 0 degrees up to the 15 degrees. And then you will have the radius at this portion of 15 degrees. Now for the beta, if the beta is equal to, for example, beta is equal to 45 or 60 degrees, you have there 60 degrees, therefore you are moving from 0 degrees to 60 degrees. That's why we have here the beta as rotating from the 0 degree axis until the 60 degrees. Then using also the radius. So if we have the coordinate, we have here the radius and the theta. Alright, so that's how we locate the coordinate for the polar coordinate. Now as for the area, we have there the area strip sector, and the derivative of A is equal to 1/2 r squared and the derivative of theta. That's why we come up with the area as 1/2 r squared d theta with the lower limit alpha and the upper limit beta. So this is what we want to remember. Now let's solve the following examples. Examples 1 to 4. Now here again, just like we did in the previous video on finding the area inside the rectangular coordinates, we need to sketch first. So how do we sketch here polar coordinate? Given here the equation r, the radius here is r is equal to 2a cosine theta. We will be needing this table to guide us on where to locate the points in this polar coordinate. So for us to fill in this table, we need to find the value of r given the value of theta is equal to 15 degrees. So basically, you will just have to input in your calculator r is equal to 2a cosine of 15 degrees. So let's have our calculator. Where's the calculator here? Oops. So we have there cosine 15, 2 cosine 15. 2 cosine 15 equals 1.93. This is 1.93a. Then we proceed to cosine 30. So what is 2 cosine 30 is 1.73a. Cosine 45, so we have there 1.41a. Cosine 60 is equal to 1, or that is a. Cosine 75, that is 0.52a. Then cosine 90, that is 0. Okay, so we can go on and on and on until we fill the entire table. But if you want a faster way using your calculator, again, if you're allowed the calculator, you can use your, okay, I'm currently using, for those who will be asking, I'm using Casio f of x 991ES right now, plus. So I'm using Casio f of x 991ES plus in this lecture right now. So you press there, mode, so press mode, then choose there number 7, table, or whenever the table is located. So I will clear this. I will choose the table. Okay, there you go. It should have that f of x equals there. Then type in the function. The function here that I will type is 2 cosine alpha x. So we have here 2 cosine alpha x. Then close it. Then press equal sign. Press equals. So just leave it there. If it's asking for the start, press 15 or put there 15. Then, because we will start at 15 degrees, then press equals. And we will end in 360 degrees. Press equals. Each step, the step that we're taking is 15 degrees. Equals, so you got there the table. Then let's proceed to the table and copy all of them here. So yes, we got the correct one for 15 degrees, 1.93. For 30 degrees, we have 1.73, 45, 1.41, 60, A, 75.52, 90, 0. Now disregard those with negative signs. We will not be using those. So disregard the ones at 150, 120, 135, 150, 165, 180, 195, 210, 225, 240, 255. Then at 270, it says there 0. Then 2.85, we have there 0.52A, 300A, 1.41A, 330, 1.73A, 345 is 1.93A, 360 is 2A. Okay, so we were able to fill in the table a faster way. Then to go back, you just have to click their mode, then math or mode in your calculator, you can just go there or click AC or all clear, and then or AC or all clear, so that you can clear off all that's inside the table, or you just click there mode, then go to number 1 computer. So that's just the faster way to using the calculator. Using calculator for the table. So degree mode, again, I will remind here, it's in degree mode. Okay, let's go back. Then finally, we can now plot the curve. So if we are plotting the curve, look at here. What's the radius at 15 degrees? It's actually, what I do here is find the longest radius. For the longest radius here, we have 2a. And then it's located at 360 degrees. This is 0 or 2 pi, or also the 360 degrees. I will put there the maximum radius, that is 2a. Then at 15, we have 1.93. So if this is 2a, radius 2a here. This is 2a, 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 2a. Imagine a cord. Imagine you are holding a string, a cord. Put the other end on the origin and the other end on the point here at 2a. So that's the length of your string, that is 2a. Now for 15 degrees here, the length of your string or your cord becomes 1.93. So instead of putting your string here at 2a, no, you will put here at this point. That's 1.93. For 30 degrees, it becomes smaller, 1.73. For 45 degrees, goes here, 1.41. For 60 degrees, it goes half of 2a. For 75 degrees, it's 0.52, so half, almost half. And then for 90 degrees, it becomes 0. So that's for the curve. So let's just follow the curve here. Just using. There you go. Next, let's go to the other part. We have the 270 degrees. This is 90 degrees. And then this is the 270 degrees. 0. Then at 285 degrees, it's 0.52. Then at 300, it's A or 1. And then 315 is 1.41. Then 330, 1.73. Then you have 345 at 1.93. So it's okay if the sketch is not that perfect. The point there is we get to have an idea how the curve looks like. That's why we are sketching the curve. Unless you're using their AutoCAD, so you can perfectly plot the curve. So this is now our curve. The boundary is r is equal to 2a cosine theta. So how will we use the area strip now? Are we going to use the horizontal and vertical area strip? The answer is no, because if you use the vertical and horizontal area strip, it will touch the boundary on 2 points. So no, it's not the horizontal and vertical area strip. Rather, the area strip that we will use here is the sector area strip. It will start from the point of origin to the boundary. So this is d theta r. So that's the area strip. Okay, now let's solve for the area. This number 1 has two solutions. So let's start with the first solution. Oh, let's write first the area. The area, again, from the notes, the area here is area is equal to 1/2 r squared d theta alpha to beta. So area is equal to integral of r squared d theta alpha to beta. Then don't forget the 1/2. So for the first solution, here is we will need to find the limits. No problem with r here because r is already given. So r is 2a cosine theta. You just have to square it here. So what we're going to find really is the alpha and the beta. So the lower limit alpha will always have lower value compared with the beta. So what we're going to use here is, I'm going to consider the half, the upper half, the one in the first quadrant here. So I'm focusing on the upper half. So my alpha is now equal to the boundary at this point at 0 degree, and then beta is where it ends. So from the table, you can also find a clue. So at 0 degrees, you got the boundary, or you close the boundary using the x-axis here and the curve. So that's why I chose the alpha at the 0 degrees. And then it proceeds to another closure. It will close at where? At 90 degrees. So I'm looking at this and this as the boundary. Okay, 90 degrees. At 90 degrees, it closes at the origin or at the same spot with the x-axis. So we have here 90 degrees times pi over 180. We will convert that into pi over 2. Therefore, area now is equal to twice of the computed area. So this is 2a. R squared is 2a cosine theta squared d theta. Boundary is 0 to pi over 2. It's too close. So that is pi over 2. So if you're solving this with Wallis formula, it's still okay. You know the long method for the Wallis formula. Okay. But if you choose the calculator, then still okay. So this is 2 times the result here. So let's use the calculator. A word of caution, if you're in this spot already, in this solution, always remember that use here the radian mode. Use rad or radian mode. So I'm changing this into radian mode. So we have there 2 so parenthesis 2 cosine alpha x, close it with parenthesis, squared. Lower limit is 0, upper limit is pi over 2. Shift pi over, so shift pi over 2. The answer here is 3.14, or that is pi. So the answer here is 2 over 2. Okay. Pi a squared. Therefore, it is equal to pi a squared, square units. Don't forget the a squared here, because in the equation, there's a presence of a. In the calculator, we did not put a here because it will become another unknown. So that's the answer. First solution. Now for the second solution. So second solution, considering it as a whole. We will consider the whole drawing here, the whole figure. So if I'm considering it as a whole figure, therefore, I will start at 0 degrees counterclockwise and end at 0 degrees. So I can do that. Or we can have it as 270 degrees to here. It will close at 90 degrees. Remember that the boundary closes at 0 to 0. I should correct that one. So 0 to 0, the origin to the origin. Meaning, at radius 0, that's where it closes. So the point here is 270 degrees and 90 degrees. So we will start at 270 degrees, then close at 90 degrees. So how will we do that? So we have here alpha at 270 degrees, because that's where the 0 is. That's where it closed. So 270, this is 3 pi over 2. As for the beta is, take note, 270 reaches 360, and then another revolution. So 270, 360, and then another one. Means 360 plus 90. This is 5 pi over 2. So the area now is equal to 1/2 integral of 2a cosine theta square d theta. Alpha is 3 pi over 2. Beta is 5 pi over 2. So area now is equal to I will just have to repeat 2 cosine alpha x squared. Then we have here sorry about that. We have here 3 shift pi over 2. Then we have here 5 shift pi over 2 equals so we have there 2 pi. So we have 1/2 2 pi a squared. So that is equal to cancel 2. We have there pi a squared square units. So, at the 2 solution, we still arrive at the same answer. So, either of the 2 solution you will use, still okay. The good thing about this is that you can check if your solution is correct or the answer is correct, because there are more than one solution you can use. So that's for number 1. Now let's proceed to number 2. For number 2, let's fill the table first so that we can sketch the curve. So let's go back to the degree mode for the table. Now this is something you need to be very careful about. It's when you have your calculator in radian and degree mode. For the table, we will use the degree mode. Okay, so in degrees, use degree mode here, just to remind everyone. Again, let's go to mode, table, then type in the function. We have there cosine 3 alpha x equals start 15 and 360 step 15. So we have there, so it is 1 over square root of 2. So number 15 is 1 over square root of 2a. 30 is 0. 45, you can use that. 60, 75, 90 is 0. 105 is 1 square root of 2a. Then we have 120 as a. 135 as 1 over square root of 2a. 150 is 0. 165, 180, 195, 210, 0. 225, 1 over square root of 2a. 240 is a. Oops, took slot 9. 255 is 1 over square root of 2a. 270 is 0. 285, 315. Then 330 is 0. 345 is 1 over square root of 2a. 360 is a. Alright, so clear this one. Mode complex math. Okay, what is 1 over square root of 2? That is equal to 0.707 or 0.71. You can use that. That is 0.71 here. 0.71. Then we can have here 0.71 also. It's easier to plot. Alright, so there you go. Sorry for plotting so slow, but I hope this proves to be helpful. Alright, then let's plot it at 360 degrees. So the longest side is, the longest radius is a at 360. So let's put here as a. This is a. Then at 15 degrees, it becomes 0.71. Then at 30 becomes 0. So it goes like this. Oops. There you go. Then let's go to the next table. We have there 90 as 0. 90, then 1.5 0.05 is 0.71 here. Then we have 120 as A. 1.35 as 1 at 0.71, then 150 at 0. So again, let's plot that. It's not that perfect, but I hope you get the idea. Then let's go to the 210 at 0, 225 at 0.71. So approximately here. 240 at A, 225 at 0.71, and then 270 at 0. Then we have there 330 at 0, 345 at 0.71. So, and then 360 equals 0 at A. So this one here. So this is the figure. Now again, let's have the area strip. There you go. This is d theta, then r. Now, how do we solve this one now here? We can have here at 4 solutions. Actually, you can have 4 solutions for this. The first one is I will consider the petal here. The first petal in the second quadrant, the 90 to 120. So the boundary that I will get is the 90, which is the 0. Take note. 90, which is 0 here. And then the 120, which is the A. So let's have the first solution. Half petal. So area is equal to again 1/2 integral of r squared d theta alpha to beta. So that's our area. Now for the area of the half petal we have there, how many half petal do we have? So we have 6. 6 half petals, 1/2. The radius is, we have there cosine 3 theta, A cosine 3 theta. Cosine 3 theta d theta squared, and alpha to beta. Let's get the value for alpha. Our alpha is 90 degrees, as I pointed out earlier. Pi over 180, this becomes pi over 2. For the beta, we have 120 times pi over 180. That is equal to 2 pi over 3. Therefore, the area here is 6 1/2 A cosine 3 theta squared d theta. Then alpha is pi over 2. It's too close. Okay. Then beta is 2 pi over 3. Now, area now is equal to, this is 3 times the area that we can solve, or the what we can solve here. Okay, clear. Again, remember, this is in radian mode. Rad. So we have there integral of cosine 3 alpha x squared. We have there shift pi over 2. Then 2 pi over 3. 2 shift pi over 3 equals pi over 12. Therefore, area now is equal to, forgot. There should be a squared here. See? I almost forgot the a squared. So area now is equal to pi a squared over 4 square units. You can have it in decimal, still okay. So I just wanted it in pi. So that's the first solution. Let's go to the second solution. Second solution. The second solution is the whole petal. So alpha is equal to, if I'm considering the whole petal here, on this petal here, we have alpha as 90 because it's 0. Alpha 90. And then the angle where it closes, that is the zero radius, 150. So 90 to 150 from this table here. So 90 to 150. So my alpha is 90. That is pi over 2. And then my beta is 150. Because that's where it zeros. The radius becomes 0, or that is where it closes boundary. So this is 5 pi over 6. How many petals, whole petals we have? We have 3 whole petals. 3. 1/2 integral of a cosine 3 theta square d theta alpha of pi over 2 beta of 5 pi over 6. So area is equal to 3 halves times let's change the limits, becomes 5 pi over 6 equals pi over 6 a squared. Therefore, area is equal to pi a squared over 4 square units. Still the same. Now for the third solution. For the third solution, if ever you consider the petal here at the third quadrant, the alpha there becomes, this is a practice on how you determine your limits, alpha and beta. If you're going to use the petal on the third quadrant, so the 0 to 0 here is the 210 and the 270. The 210 and the 270. If you are considering the petal here at this portion here, you have the alpha at 330, and where it closes again will be at 30 degrees. So meaning you go the revolution here to that point. So let's see, let's put that in the third and fourth solution. For the third solution, we determine the alpha as the 210 times pi 180 equals 7 pi over 6. And then the beta is 270 times pi over 180 equals 3 pi over 2. For the fourth solution, you will have the alpha as 330 times pi over 2, pi over 180, sorry. That is 11 pi over 6. And the beta is 360 plus 30 times pi over 180. That becomes, no, it's 13 pi over 6. Now, let's watch if they have the same answer of pi over 4. Don't forget, we will multiply 3 halves because there's 3 of them. Let's see if we can arrive at the same answer as pi over 6. So the third solution is 7. 7 pi over 6, and then the lower limit is 3 pi over 2. Answer. So negative pi over 6. Oh, this should be 7. Oh, sorry, it should be 7 over 6. So 7 over 6. Then this one here is 3 pi. The upper limit, the beta, is 3 pi over 2. Pi over 6. There you go. And then for the fourth solution, we have the alpha as 11 over 6. So 11 pi over 6. And then the upper limit beta is 13 pi over 6. Again, pi over 6. So you can use those limits. So this is for number 2. Let's go to number 3. We have there r is equal to a 1 minus sine theta. Again, let's fill the table. Clear. Going back to the degree mode. Again, warning, this is degree mode. So we have there a 1 minus sine. So again, it's mode. Table 1 minus sine alpha x equals 15, 360, 15. There you go. Ooh. So let's have, I don't know how to convert this into okay. Okay, so let's have number 15. The decimal for number 15 here is 0.74. So that is 0.74a. Number 30, this is going to be a lot of work, 0.5a. 45 is 0.29a. 60, 0.13a. 75, 0.03. Oh no, this is going to be a lot of work. 90, 0. Then we have 105 as 0.03. Unless you know already what's this equation, what this equation is. 120. I will show you what that is by sketching the curve. 135.29A. I'm so thankful if there's a calculator here for the table. 0.74A, and this is A for 180. 1.95 is 1.25 or 1.26A. 210 is 3 halves, 1.5A. 225 is 1.71A. 240 is 1.87A. Let's go to 255, 1.96A. 270 is 2A. 285 is 1.97A. Or it should be 1.97. 1.97. 300 is 1.87A. 315 is 1.71A. 330 is 1.5A. 345 is 1.26A. Then 360 is A. Okay, so I do hope we can sketch this correctly. It took a lot of effort. Okay, so there's no negative here, so we are going to use all of them. At 90 degrees, we have there 0. At 75, so the longest radius here is 270. The 270 has 2A. So I'm going to put here 2A here. And then at 90, we have there 0. At 105. Okay, so at 15.74, so we have their point. So this is, if this is 2, and this is 2 here, this is 1, therefore 0.72 is here. 30, half, almost half. 45, 60, 75, then 0. 0 for 90, 105 is 0.03, 120, 0.13, 135 is 0.92, 0.29, 150 is 0.5, then 160 is 0.74, 165 is 0.74. So let's put it here. I hope I'm doing this right. Okay, 135. And then we have there the 180 as A. So this is 180 A. At 360 we have also A. So at 195, 1.26. It's bigger. 1.5, 1.71, 1.87. Okay, so you get now the idea of how it looks like. It's a heart, cardioid. So it's a cardioid. This formula of R is equal to A1 minus sine theta is a cardioid. So for the math geeks out there, if you want to court someone, just send them this formula, IR equals A1 minus sine theta U, because it is a heart and it requires effort in sketching, and it makes sense. It's a heart. Okay, so we have here a cardioid, and we are looking for the area inside this cardioid, inside this heart. Okay, so there's a solution here. We can have the first solution, but first we need to put the guide 1/2. r squared d theta alpha to beta. So for the first solution, we have there the, we will be taking the half of the heart. So alpha, I'm going to take this half here. Where it closes at 90. Then another boundary is at 270. 270 is here, 2a. Alright, so alpha is 90 times pi over 180, and that is pi over 2. Beta is 270 times pi over 2, and that pi over 180. Sorry, pi over 180, and that is 3 pi over 2. Therefore, alpha, or area, is equal to twice 1/2 of a1 minus sine theta squared d theta. Alpha, pi over 2. Beta, 3 pi over 2. Calculator again. So clear, and always remember that we are mode math. Okay, so we're using the radian. Okay, and radian. So integral of 1 minus sine theta, sine alpha x squared, pi over 2, so shift pi over 2, then shift, it's 3, so 3 shift pi over 2, that is equal to 3 pi over 2. So that's equal to 2 over 2, 3 pi over 2a squared. So area now is equal to 3 pi over 2a squared square units. Now let's go to the second solution. For the second solution, we will now consider the whole heart. We are considering the whole heart. Let's start with the 0 to 0, origin, which is 90, and then end at 90. So start from 90, end from 90, meaning your alpha here is 90 degrees, and then your beta is 360 degrees, 360 plus 90 degrees. So we have here alpha is equal to 90 pi over 2, beta is equal to 360 plus 90 times pi over 180, and that is equal to 5 pi over 2. So area now is equal to 1/2 integral of a1 minus sine theta square d theta, alpha of pi over 2, beta of 5 pi over 2. So let's have the lower limit pi over 2, and then the upper limit is 5 pi over 2, and that is 3 pi. So area is equal to 1/2 3 pi a squared. So area now is equal to 3 pi over 2 a squared square units. And it's the same with the first solution. That means the answer is correct. Now that's for number 3. First solution, half. Second solution, the whole. Let's proceed to the last example, number 4. This time, what will happen if the radius is squared? We have there r squared is equal to a squared times sine theta plus cosine theta. So what will happen then? We need to take note that this means we have 2r. The radius here is equal to a square root of sine theta plus cosine theta. That's the first r. The second r will be negative a square root of sine theta plus cosine theta. But again, we will not use the negative one because in the table, it will become negative. Therefore, we will use this positive root. Now, if we are using this root, meaning there is 2r. So, another r is equal to square root of sine theta plus cosine theta. Meaning, we're going to do this solution twice. The reason is the graph is superimposed, meaning it is on top of the other, or it is on top of the other. So the graph is superimposed, or it is on top of the other. Therefore, whatever area that we will solve in this problem is multiplied into 2 because there is a superimposed graph here, or it has 2 roots. Okay? Now, let's have the table. Clear. Again, this warning here, it should be in degree. The table is in degrees. Mode, table, type in the radius. The radius, the root. We have there the square root of sine alpha x plus cosine of alpha x equals 360 step. So we have here the decimal of 15 is 1.1. 1.1a, 30, 1.17a, 45, 1.19a, 60, 1.17a, 75 is 1.1a, 90 is a. Then we have here 0.84 a, 120 is 0.6a, 135 is 0. So this ones here is already too big, complex. So 150 cancel, 165 imaginary, cancel this, 195, 210. Nope, cancel that one, too big. Imaginary, next 240. Cancel that one too. Cancel. Cancel 270, 285. Then 300 is, cancel that one also. 3150, 330, 0.61a, 345. 0.84a, 360 is a. Then close mode math. Okay, let's plot this here. So the longest here is 1.19 at 45 degrees. So 1.19 at 45 degrees. 130 is 0.17. 15 is 1.1. At 360 degrees, it's 1. Okay, see here. Right? At 60 degrees, we have 1.17, 1.1, 90 is 1. Okay? And then 105 is 0.84, 120 is 0.6, 135 is 0. 0.30 is 0.61, 0.6. And then 345, 0.84, 345, oh, sorry, I'm putting it on the wrong. So 0.3150, 330 is 0.61, 330 is, 345 is 0.84. Okay, then let's have this graph. Okay, so there we go. That's the graph. Meaning there's twice of this in this graph here. So let's solve. Area is equal to 1/2 r squared d theta alpha to beta. Now our alpha, so let's solve this as starting at 0 at 315, ending at 135. Okay, start at 315, then plus 360 plus 315. Okay, so it's in here. Alpha is 315 because that's where it closes. 7 pi over 4. Beta, on the other hand, is 360 plus 135. Pi over 180, and that is equal to 11 pi over 4. Therefore, our area now is equal to 1/2 integral of, that is a square root of sine theta plus cosine theta squared, then d theta. Alpha is 7 pi over 4. Beta is 11 pi over 4. So area is equal to 1/2 times. So again, this is in radian mode. So we have square root of, oh, that's cancel the square root, so it becomes sine alpha x plus cosine alpha x. Lower limit 7 pi over 4, and upper limit 11 shift pi over 4. So the answer is 2 square root of 2. 2 square root of 2, or that is 2.828. So area now is equal to square root of 2 a squared square units, or that is 2.828 a squared square units. Okay, so that's for number 4. Oh, by the way, I should have it should be times 2. Cancel. Oh, it should be times 2. Sorry about that. Should put here times 2. Okay. Times 2 of that. Times 2, cancel, so this becomes 2. Square root of 2. That's what in the calculator is. So 2 square root of 2. Just need to verify. Okay, it's correct. Alright, so that's it for this video. Okay, I hope you learned here. Thank you.